Hello again. This is part 2 of video 4 for projectiles. What I'm going to do in this video is finish the problem, and the way I'm going to do that is I'm going to solve section 2 right here. So if you watched the previous problem, we're solving basically this whole thing. How long, how far, when it strikes the bottom, all these fun things. So we've solved all of the arc information. I placed it right here. Now what we're going to do is we're going to start at this location. So let me take it out of the problem so I have more space to work with. So actually, you know what, I'm just going to go ahead and just do a new page because it's getting crowded over here. But I will refer back to all the stuff that's in here. So I'm just going to exaggerate that. So that's the cliff right there. Okay, so if you notice what I did is I usually cut it off right here. I'm going to start here. That's my start point. Now, from the previous video, we found that the velocity here was 39.17, I believe, or something along those ideas. So by symmetry, we can assume that the velocity at the other point is negative 39.12. So I'm going to write that in. Velocity at that point in the y is negative 39.12. Now remember that velocity is two parts, it's y and x. So I'm just going to just talk a little bit theory here, is technically the x hasn't changed. So that's still the 51.19. Let me just verify that number. 51.91. So let me just fix that. 91, oh I have it right, okay. So technically Vx is the same no matter where I pick. Even if I pick some random spot right here, Vx is the same, or here. It's the y that's changing, and just to let you know or try to visualize, remember that y is representing the up and the down. So it goes up, slows down, gets to the top, and then it speeds up. So that's the y, but the x stays the same. It stays moving forward. And the reason, again, is because there's no acceleration in the x, because gravity only acts in the y. So what we got to figure out is the final velocity y here, which is not 0. We need the time it takes to fall there. And then we need to figure out, so the last question says that this thing is going to strike, if you notice, at an angle, right? Because it's not only striking with a Vy, but it's going to have a Vx. So that's what that question is asking, is what's the velocity there? So we need to find the Vy final, which is essentially that, and the Vx, and make a triangle to figure out this angle and how much it's striking. So that's the other question. I'll get to that in a second. So let me just put a side note there. All right, so I want to figure out how the start with time. This is 125. So we actually have that piece of information because if you notice from here to here is 125. So if you want to label this out, it's kind of helpful. I have negative 125 meters as my delta y. I have my negative 39.12 meters per second as my initial. I have Vx as 51.91. And I have my A as negative 9.81. So again, you have a lot of information already, which is kind of nice. So I'm going to go ahead and find the time it takes to fall from here to here. So I have delta y, Vi, and A. So I don't like to use the quadratic. So I'm actually going to skip time now that I see that it would be quadratic, and go for Vy final. And solve that first. So let's solve Vy final. I have final initial acceleration delta y. I like to use this one because there's no time involved in this. This is the nice equation. And I can find my final velocity. So actually it's pretty quick. Oops, I guess I should be plugging in my numbers here. So let's go ahead and do that. So this is what I'm solving for. My initial is negative 39.12 meters per second. This whole thing will be squared. Then I'm going to say plus 2, negative 9.81 And since it's falling, this is negative 125. So let's find that out. So 39.12 squared plus 2.81, 125, square root my answer. This becomes 63.11 meters per second. I'll throw in the negative sign here to represent the fact that it is moving downward at this point, which we can assume since it is falling. Great. So we got that. Now I'm going to find time. That it takes to do that. I like to use this one because it's pretty simple. And it has acceleration, which we always have, so that's really nice. So using these numbers, we're going to go ahead and find the time. That's the initial. So the time it takes to fall here (2.43 seconds). Great. So we have the time, 2.43 seconds. So that's really good because now that we have the time here and the time there, we have the total time, right? So total time is going to be the time of the arc plus time of the extended fall, so time of the fall. So let's take a quick look at that. So I got 7.98 for the arc. Plus 2.43 for the fall. (10.4 seconds). And there you go. That's the total time. So that's one of the questions answered. Another question is how far did it go? So we got this as 141. I'm sorry. What's the value that we got there? Let's take a quick peek. Oh, I guess. 414.1. Okay. 414.01. That's from here to here. Now we're looking for this. The good news is we know how long it took to fall from here to here. So during that time, it should be the same time it took to go from there to there. So in other words, we know the time here, which we do, is 2.43. We can find x. So we're going to find the x that I have labeled there. It's going to come from the constant velocity equation, which will be Vx. So Vx is the 59, right? 59.91. And we have the, so that's the, and then we have the time, which is 2.43 seconds, like that. So we could solve for how far it went by multiplying those two numbers. 59.91 times 2.43. I get 145.858. Okay, this plus this gives us the total range. So total range is going to be the 414.01 plus 145.58. I get 559 meters. So roughly 560 meters when you solve it out. Okay, so we got another piece of that problem. Very good. We found the total time, the height, the range. Now the last part is this thing right here. So let me actually get a new page for a second and talk a little bit about what it's asking. So this is the ground. Now, when the object strikes the ground, it's going to strike it at an angle like this. That's because it is falling and at the same time moving horizontally. So when it says what's the velocity at which it hits the ground, it wants this part. So the hypotenuse of this triangle that is made, which represents both velocities. Now, pay attention to the problem. If it wanted Vx, it would say I want the horizontal component. If it said what is the vertical component at which it struck the ground, that would be Vy. But since it said what's the velocity, it wants both. So this becomes a trig problem. So Vx is constant. Remember, that number does not change throughout the whole problem. So that's the easy part. This is what we solved earlier. This is that number we got. Let's take a step back. When it struck the ground. So that's negative 6311. And notice, that makes sense, notice that the arrow is down, which is where the negative comes from. So essentially, this becomes the Pythagorean theorem. What is the hypotenuse of this? We have A, B, let's solve for C. So V in equation form is Vx squared plus Vy squared square rooted. So there we go. Vx squared is the 59.91. This is the 63 part. Shortcut is this squared becomes positive, so you don't actually have to put that into your calculator if you don't want to. Remember to square root, it shouldn't be in the thousands. 87.02 meters per second is the value of the velocity at which it strikes the ground. But it's going to make an angle to the horizontal, so we need to find this piece. Now you can use any components of SOHCAHTOA to find this. So I like to use tangent, it's just my personal favorite, but you can use any. This is opposite over adjacent. So tangent is going to be opposite, 6311. And then adjacent is the 5991. And then to find the angle, you have to actually take the inverse tangent. So it's actually going to look like this. And then when you plug this into your calculator, you have to press second tan 63 divided by 59.91. And the final answer is negative 46.49 degrees. Now, the negative represents that it's below the horizontal, which is what you should expect, because if you continue this out, this is actually below the horizontal. So actually, I apologize. Let me take a quick step back. If this is the opposite and this is the adjacent, I solve this angle right here. So the question then is, that's the correct angle that I solved for. And notice that this angle by an alternate interior is the same angle here. So this is the angle that is below the horizontal, which is what we want. This is the problem that we're solving here. Let me just take a quick peek at the problem. The angle made with the horizontal. So yes, that's the correct angle that we want. So I apologize for labeling the angle incorrectly before, but this is the correct angle because that's the angle it's made with the horizontal. So it goes below like that. So that's what the negative means. It means below horizontal. So technically, you can just write 40, let's round, right? We could do 46.5 degrees below horizontal, and that also would be correct. So yeah, so that's the whole problem. It's long, but it's not too bad if you break it down into parts. That's the biggest thing, is always break it down into manageable parts. Because remember, these equations don't solve one big problem, they solve lots of little problems. All right, I hope this was helpful and best of luck.